Alright, so here we go. The second video for the semester exam review of 2016. Alright, so what do we do here? Okay, so what we have here is a problem where we have to say, like, use MapMan. And again, MapMan means that when you multiply, you add the exponents. When you have parentheses, and well, you got the idea. That's just supposed to be a period. You multiply the exponents, and then when you add, you do nothing with the exponents. Now keep in mind that when you're saying this, that you also say when you divide, you subtract the exponents. Okay, so there's that. Keep that. That's something you could add to your note card easily. And so what does that mean? Okay, well, the different properties are available right here. Okay, so you can see here you have this little exponent right here. It needs to multiply exponents. Now everything in that parentheses has an exponent. So even the 5 and the t have an exponent. So I'm saying 5 times 2, 2 times 1, good grief, I was going to get that right sooner or later, is 2. 2 times 2 is 4. 2 times 1 is 2. Okay, that is multiplying 3 times r to the 0 t to the 4th. Now start adding the exponents for the ones that are the same. So 4 plus 0 is 4. 2 plus 4 is 6. And then the big numbers, the coefficients, I guess you could say, there, you can just multiply. Type that in your calculator. 5 squared times 3 on your calculator, and you would get 75. And that's it. There you go. Done, all done. So there's that one. So again, notice how I multiplied when I had the parentheses, and then I added when I was multiplying, and then kind of went from there. Now, for this one, this is dividing, so I need to subtract the exponents. 4 minus 2 is 2. 1 minus 7 is negative 6. 5 minus 1 is 4. So you can kind of see like how I try to approach these, where I'm just worrying about the exponents. I'm not even worrying about these numbers just yet. Okay, the negative 6 needs to become positive, so I send it to the bottom. A squared C4. And then I can type in 2 over 18 on the calculator. When I typed in 2 over 18, you're going to get 1 over 9, which means you can just put the 9 here, and that would be your answer. I mean, you can put the 1 up there, but this is multiple choice, so I wouldn't have to put the 1 there. So there you go. And that's it for, say, the exponents. Alright, so now we have some that are talking about simplifying. Well, simplifying should be easy. You want to put like terms together. At least for 26 and 28, you want to put those like terms together. So this minus here means I'm going to change the signs of everything in here. So as I'm writing them under, 1 it becomes positive 1 becomes a minus 1, plus 2 becomes a minus 2, and minus 5 becomes a plus 5. Now notice how I've lined them under, squares, c's, and numbers. 4 minus 1 is 3, c squared. Negative 12 minus 2 is negative 14c. 5 plus 7 is 12. And that's it. Same thing here, although maybe because there's a plus, that means you won't change the signs of these. So you have 5p squared plus minus 4p minus 12. Notice how the 12 is kind of off to the side. 9 plus 5 is 14p squared. 7 minus 4 is positive 3p. And then you have the negative 12. Whoops. Let's try that again. Ooh, there we go. Okay. And then for 3x plus 4, 2x minus 5, I could do something like this. Okay. Keep in mind that on 27, there's 3 different ways I could ask that question. I could say just simply multiply those. If y'all didn't hear my cat, she's telling y'all multiply. Or I could tell you to find the area. Apparently she's agreeing with the whole find the area. And I could write it out in words, find the area. Yes, I like how my cat will like say constantly be bugging me, but my dog knows good enough to say just go ahead and say leave him alone. Anyways, alright, so there's all that. Now, there's 3 different ways we can multiply, depending on what you like. I prefer 3x plus 4, 2x minus 5, the vertical method. The vertical method means it's like two-digit multiplication. You say negative 5 times 4 is negative 20. Negative 5 times 3x is negative 15x. So you're multiplying this way and that way. Then you put a 0 and you say 2x times 4 is positive 8x. 2x times 3x is 6x squared. Notice how it goes x squared, x number, so I can easily combine these, 7x minus 20, and get my answer. Distributive property would tell me that I would say 3x plus 4 and go 2x minus 5, 2x minus 5, and then distribute. So 3x times 2x is 6x squared. 3x times negative 5 is negative 15x. 4 times 2x is positive 8x. 4 times negative 5 is negative 20. And then notice how these two can combine. You get 6x squared minus 7x minus 20. Now you can see here we're getting the same answer and the same numbers from the multiplication. It's just a different way of organizing. The box method, you get to draw a box. Ooh, you get to draw a box. 2x minus 5. And again, you do the same thing, multiply. You're going to get the same numbers. The only difference is how you combine. You combine these two to get the same answer, 6x squared minus 7x minus 20. So there's all three methods right there. You can kind of go from that. That's pretty much it. So, yeah. Decide which method you like using and then use it. Alright, so now we're to the radicals. Okay, so if you don't have the perfect square table written yet, even though I keep telling y'all to write it, then maybe you should write it. So here's the square root table, or the perfect square table. Okay, so magically it appears. Yay! Okay, but here's the perfect square table. You can kind of see how it works and kind of go from there. I put in probably more numbers than you might need, but hey, this might make things easier for later problems. Who knows? Anyways, okay, so and we'll come back to the cubes and stuff like that later. So if you go to this and say, okay, perfect square, okay, square root of 18. Well, there's no square root of 18 according to the perfect square table, but the largest of these numbers that goes into 18 is 9. So 9 and 2, and the square root of 9 is 3, and then you put the 2, and there's your answer, 3 square root of 2. Here, the largest that goes into 54 is also 9, with an answer of 6. Take the square root of 9, you get 3, with the square root of 6. So the idea here is that the first number that you write, that perfect square, will be able to divide, or I'm sorry, it divides into that number under the radical. Then that's the one you can take the square root of, and you can see here, like if you say the square root of 9, you're saying it's 3. If you say the square root of 169, it's 13. Okay, so there's that. And then the answer that you're getting when you divide, that's going to stay under the radical. So here I see square root of 192. The square root of 192 is, well, that's a very good question, Alex. I don't know. No, okay. Now, anyways, let's see here. What's the square root of 192? Just 1 second. I got to remember. It takes me a second here. Okay, so, but again, you want to start with the highest number under that, and maybe about halfway. So let's say like 100, and then you go to like 100, then like say 81. So I'm going, okay, 100 doesn't go into it, 81 doesn't go into it, 64 does go into it 3 times. Okay, so and notice I'm not worrying about this right now. I'll come to that in a second. So what's the square root of 64 according to the table is 8. Square root of 3, and now I can put the negative in front. Because that negative was in front, it just makes everything negative. Here, 8, the largest number that goes into 8 is 4, perfect square, and the square root of 4 is 2, so I get a 2. That 2 needs to multiply the 6, so that means 12 square root of 2. Okay, so you can kind of see how those work. They shouldn't be too difficult. Again, there's your perfect squares table. Use that. So when there's a number on the outside, you will save that for later, and you know you're still going to work this like you didn't see that number. Take the square root of 25, that's 5, square root of 3. Okay, 5 times 7 gives me 35. So you take that number that's on the outside and multiply it to the original number that was outside. And there is, when you look at variables, you see if you can get them in pairs. There are no pairs of x's, so it stays under. Here, square root of 100 or 384 gives me That gives me 64 and 6. So again, that's one that could take a while to get to, because 384 is, I mean, you could go, let's say 160, 144, 121, 100, 81, 64. So it takes a little bit of a while, but the square root of 64 is 8. Square root of 6. So the 8 times the 3 would give me 24. Okay, then, and we've got the square root of 6 here. Now let's look at the x's, and I've got a pair of x's. So I've got one pair of x's with one x left over. And there's that one right there. Okay, so for the next few problems, you'll need your cubes and fourths tables. So kind of keep in mind that you need to pay attention to that when you need to do like the different radical symbols. So here, because this one right here tells me I need to use my cubes table. And so I look at the 54, and the largest cube, perfect cube that goes into 54 is 27. 27, and 54 divided by 27 is 2. Now the cube root of 27 is 3. And then you can put here cube root of 2. Now the variables go a little bit different. Whereas on number 34 we had to do them in pairs, now we want them in groups of 3. So if you look at 6 x's, you get 2 groups of 3, so that would be x squared. If you look at the y's, you only get 1 group of y's with 2 left over. So there's 1 group that goes out, but there's 2 left over, and that's how you get your answer. Now, for number 36, okay, 36 here I have the square root of 48 now, but it's fourth root. So now I need to look at the fourth roots. So I look at the fourth power ones, and the largest one that goes into it is 16. 48 divided by 16 is 3. And the fourth root of 16 is 2. Fourth root of 3. Why did I write third root of 3? Fourth root of 3. Okay, and then x to the fifth, now I want them in groups of 4. So there's one group of 4 with 1 left over, and there's your answer. Okay, so kind of keep in mind what you have to be careful with on those. Okay, so then you go over here to 37. Here's another one that's a cube root. So I'll go back to the cube table. And again, this one is going to ends up being 64. And then 320 divided by 64 is 5. The cube root of 64 is 4. And then you get the cube root of 5. Now I need to multiply that 4 times 3 to get 12. Cube root of 5. And then x to the ninth, 9 x's, will give me a group of 3. 3 groups with none left over. So then my answer for this one is 12x cubed, cube root of 5. So 38, how can I do 38 and 39? Well, the way you could do them, one way, is you could simplify them at the beginning. Or you could just multiply. Say 2 times 4 is 8. 20 times 10 is 200. See, when you multiply, you can just straight multiply. But you got to multiply the outsides and the insides. Then I can simplify this, and the largest perfect square that will go into 200 is 100. 200 divided by 100 is 2. The square root of 100 is 10. Square root of 2. But now I need to multiply that 10 times the 8, so my final answer is 80 square root of 2. Here, 4 times 1 is 4, 3 times 12 is 36, and the 36 is a perfect square. You don't say. It's 6. And then I can just say 6 times 4 is 24. Ooh, that one's simple, sir. Adding and subtracting. Guess what? These need to be the same, and then you just add or subtract the exponents. I'm sorry, the coefficients. The numbers in front. So 2 minus 3 is negative 1 square root of 6, or just negative square root of 6. So these shouldn't be too difficult per se. You just kind of got to work through them as you need to. Here, you've got negative 3 minus 1 is negative 4 square root of 3. So they're already the same, and there you go. Notice how the square root of 3 does not change. Here, they're not the same. So what do? Well, let's simplify. Square root of 20, the largest perfect square that goes into it is 4. With a remainder, or 20 divided by 4 is 5. Square root of 4 is 2. Square root of 5, multiply that 2. So I now have negative 1 square root of 5 minus 2 times 2 is 4 square root of 5. So negative 1 minus 4 is negative 5 square root of 5. So there you go with that one. Here, this one's basically the same thing, 4 and 5. Square root of 4 is 2. Square root of 4 is 2, so I get 2 times 3 is 6. Square root of 5, 3 square root of 5, plus 3 plus 6 is 9. Square root of 5. Bada bing, bada boom, there you go. Done with those. Alright, so now we're getting to this last little bit, and I don't know how much further I'll go with these before I stop, but let's look at this and let's say, okay, because of this negative, every single one of these, the first thing you need to put is an I. Okay, and then look at it as a 60. Notice once I put I, I'm no longer saying minus or negative. Okay, the largest perfect square that goes into 60 is 4. The square root of 4 is 2, so I have 2I square root of 15. Okay, here, again, I square root of 63. The largest perfect square that goes into 63 is 9. Square root of 9 is 3. So I got 3I square root of 7. Here I have 7I. Now looking at the square root of 40. That's 4 and 10. And the square root of 4 is 2. So 2 times 7 is 14I square root of 10. So you see here, these are basically the same like as the other previous radical problems, but the difference here is that I. So here I have 5I square root of 90, and the largest perfect square that goes into 90 is 9. So that's square root of 9 is 3 square root of 10. So 3 times 5 is 15I square root of 10. So a lot of these hopefully should not be too difficult. There you go. All you got to do is, if you know your multiplication tables, this really should make that much easier. Okay, so for my last two, I'm not going to take a picture of them. I'm just going to do 48 and 49, and then I'll finish up the others in another video. Okay, so 48, you've got 3 negative 32 x cubed. Okay, so again, here's my I. So I have 3I 32 x cubed. And just like before, find the largest perfect square of 32 that goes into 32, which is 16. 32 divided by 16 is 2. The square root of 16 is 4. 4 times 3 gives me 12I. Square root of 2. X cubed means I've got 3 x's. That means I've got one group of x's that can go outside and one that stays in. Okay, so that's it for that one. So that's all you got to do for that. Okay, the order won't matter. I mean, but it is preferred that it goes number, variable, I, radical. Okay, and then 49 is 4 square root of negative 338 x to the 6. So again, I have 4I 338 x to the 6. Okay, and the 338 is 169 and 2. Now, again, folks, if you're not sure how to get those numbers, go with like about halfway down. You can pretty much figure out what's halfway down and then start dividing. Okay, so like 170 or so. And, well, the largest perfect square from the perfect square table is 169. Okay, so luckily that would come out really quickly. You get 169 and 2. The square root of 169, according to the table, is 13. 13 times 4 is 52. And again, I'm going to put a space here, I square root of 2. Then with 6 x's, put them in pairs because this is square roots. How many pairs do I get, or how many groups of 2? I get 3 groups of 2. And there you go. Alright, so this one went a little longer than I would like, but hey, there you go. I try to go over everything for y'all and try to help y'all make sure y'all do well in this semester exam. Anyways, that's it for now. I'll get another video out to you pretty soon. Thank you very much.